Hi there, I'm Colby Smith, and I'm going to be making a rubber ball with polyvinyl acetate or white Elmer's school glue and a saturated solution of 20 ml team borax. 23. This is at 56 centimeters. Registered at about 23 again. 22. 33. This is at 33 centimeters. It registered at about 15 centimeters. Just for fun, I am going to drop it from the height of my fridge, which is about 155 centimeters. And it hit 30. Now that we finished the experiment, we can use our data set to calculate for our coefficient of restitution. Now, in order to calculate for our coefficient of restitution, we are going to be looking at this equation. Now, the little h represents our bounce, and the large h represents our initial height. So, for an example, if we did this for trial 1, we would plug our numbers in to the square root, and it would be 2 times the gravity constant times our bounce, which was 15 centimeters, over the everything under the square root, 2 times the gravity constant times our initial height, which was 33 centimeters. You put this into the calculator, and it gives you your answer of 0.603 or 0.603. Now, you should get a relatively consistent answer if you collected the data properly. You can see that here, trial 3 is quite different. What I suspect happened was that as the ball dropped from such a high height of 155 centimeters, it had so much energy that the ball released it by not only bouncing upwards, but also by cracking. It would split down the middle. So that made it difficult to get an average height. But in theory, when done properly or done without, I guess, error such as this, you will get a relatively consistent answer. The first two seem to be all right. In order to go back over this, so in order to calculate for the coefficient of restitution, it would be under the square root 2 times the gravity constant times your bounce over under the square root 2 times the gravity constant times your initial height. Thank you for watching this video.